Consider the function y equals 2x over x minus 4. Complete the table and sketch the graph. That's pretty straightforward, yes? So since you all got your calculator, you should all be able to enter this into your calculator, right? I mean, we could do this in our head, couldn't we? Do we need to take that time right now? But do we know how? So this is when I don't mind using the calculator. When we're saving time. As long as you understand what's happening here. What am I doing with the 1? Plugging it in for x because it's in the x column. So I'd say 2 times 1 is 2. And then 1 minus 4. What is 1 minus 4? Negative 3. So what's 2 over negative 3? Negative 2/3, right? Now, as long as you understand that what's happening, I don't mind plugging the rest of these into the calculator and looking at the table. Are you okay with that? Okay. So, you guys have it plugged in? Yes? So, if x is 2, what's y? Somebody tell me. Negative 2. Somebody else tell me when x is 3, what's y? Negative 6. What about 4? Undefined. Is it alright if I put UND? Are you going to understand that I'm not misspelling and? Okay. What about 5? 10? And 6? Okay. And 7? So that's been an issue today, and I want to make sure you guys understand this. Okay. If it says 4.6667, what is it actually saying? 4.6 repeating, right? You can actually arrow down. Just let me see your calculator real quick, please. When you arrow down, like he has it arrowed down right there, you can see down here what that is. And see how it goes 4.66666, and it like has an arrow that it keeps going? Please don't just write 4.6. That's not right. First of all, if you're rounding, you didn't round correctly, right? But I'd rather you know that it's 4 2/3. Do you know that 6 repeating is the same as 2/3? If you don't, you should. Okay? 4 2/3. And for the most part, I don't care if it's decimal or fraction, but this is actually more correct, more accurate than 0.67. 2/3 is all of the 6's, right? Okay. So let's go ahead and plot these on the graph, please. Okay. When x is 1, y is negative 2/3. So when x is 2, y is negative 2. When x is 3, y is negative 6. Uh-oh. What do I do? I don't just go to 0 and put it on 0? Does it say 0? Yeah, it says undefined. So what do I plot on 4? Nothing. I leave it alone. Okay? I don't plot anything for x equals 4. What about x equals 5? That's 10. And 6 is 6. And 7 is 4 2/3. Now, you already have a general idea of what this picture looks like, don't you? How? Oh, you looked on your calculator. That's fair. Would you have a general idea if all you saw was this? Hopefully, because you remember what rational functions look like. It's 2 parts. And you know that I didn't just make crooked lines, right? You know these are curves, correct? Okay. So now they want to say, first of all, how can you tell that an asymptote occurs at x equals 4? How can you tell that? It's undefined. Okay? We can tell there's an asymptote at x equals 4 because it says undefined. Okay? But I want to talk about more specifically what happens when we plug in numbers closer and closer to 4 when x is 4. Okay? So I want to talk about 3.5 and 3.8 and 3.9. Does your table have those on them? Oh, could you make them? How would you do that? With the table open, press Menu. And then choose Table. And then choose what? Edit Table Settings, number 5. Where do we want our table to start? 3.5 would be a good place to start because that's where it's starting asking its questions, right, for us. And then how do I want my table to count? By 0.1? Does 0.5 to 0.8, does that change by 0.1? No, but that does, right? So 0.1 is probably a very good choice. Now I just have to be careful when I copy it down that I don't just put -14, -18, right? Because that doesn't really match. I need to put down what it's asking for. So 3.5 is -14. 3.8 is, good job, -38. 3.9 is -78. What about 4.1? 82. And 4.2? 42. And what about 4.5? 18. So here's what's interesting to me, okay? If we're on, well, do you have a different color? If you don't have a different color, that's fine, but especially if you're a visual person, you want a different color for this, okay? We know that because there's an undefined at x equals 4, I know that's where my asymptote is. So I'm going to go ahead and draw it in. Do we draw asymptotes with solid lines? Why? They don't exist. They're not there, right? So we draw dotted lines, and I drew a dotted line on x equals 4. Where else should I have a dotted line? Y equals 2, right? That's my horizontal asymptote. My exponents are the same, so I look at my leading coefficients, 2 over 1, so y equals 2. Like that. Now see, to me, having the asymptotes there helps even more see the picture of the graph. Does that help you at all? Okay. So as I am going toward 4 from the left, right? I'm heading right, but I'm approaching 4 on the left side of 4. Does that make sense? I know it's confusing with the left and the right words, but I'm coming like I'm doing domain just like normal from the left, but I'm approaching the 4 from the left here, right? Okay, so what's happening to my y values as I get closer and closer to 4 this way? They're getting like way smaller, right? Some people said earlier they're getting bigger but negative. I mean, if that's how you understand it, then that's fine, right? But these numbers are getting way, way, way tiny, aren't they? Okay, so how should we say that? Like, but what's going to tell us the numbers are decreasing? What am I doing? The y values are decreasing when what happens? The y values are decreasing as I get closer to 4 on the left side of it. Are you okay with that? Because I'm going right, but it's on the left side of 4. So what's happening on the other side? What happens when I'm going backwards, like toward 4, but this way? They're getting really big, aren't they? Now, I mean, relatively speaking, 82 is not really a big number. I mean, some of your grades aren't even that high. Sorry, that was just a little joke. They're getting there, right? They're getting there. But if we're talking about numbers like -2 and -6 and 10 and 6, 82 is pretty big, isn't it? Okay, so the y values are decreasing as I get closer to 4 on the left. The y values are increasing as I get closer to 4 on the right. Does that make sense to you? So what kind of asymptote is this? Vertical. Would you know that without the title being vertical? Right? Because it's straight up and down, right? Vertical. It's a vertical asymptote. Okay? So let's do a little bit like we did yesterday. Yesterday we did some exploring by doing some stuff the long way, figuring out a pattern, and now we know the short way, right? Okay, so let's do it again. There's 7 tables back here to fill in. Choose one, come fill it in. If somebody else already did it, okay, you already have the answers written down. But I need all 7 of these filled in before we can go on. Do I need to assign them, or are you going to volunteer for them? Assign? That makes you feel better when I assign you stuff? Awesome. All right, you do 1. Yeah. Tegan, you got 2? Bella, you got 3? Hayden, you got 4? Matthew, you got 5? Riley, you got 6? Justin, you got 7? Now, you all still do 1. Just because I didn't assign you 1 doesn't mean you don't do 1. Go ahead and choose 1 and do 1, because guess what? You're going to have to write them down anyways. Right? So if I assigned you 1, get it done, and then come back and put it on this sheet so we can talk about them together. Please. Nice. Thank you. Good job. Yep, nice. Nice. Good job. Excellent. It's not hard. You did fine. You got them copied? Almost? Okay. Yeah. I mean, you can do them all on your own if you want. I'm just saying they're right here if you want to copy them. You guys are done? Are you guys done? McKenna, is your table done copying? Bella, is your table done copying? Almost. Peyton's your table done copying? Okay. All right, ready? Okay. So what we have to do, it says use table to determine the location of such asymptotes for the following functions. Okay? So what we want to do is see if we can eventually not have a table, but just be able to look at the equation. So what I want you to do right now is choose one. It doesn't matter which one you choose, and you can choose a couple if you want, but look at the equation and look at the table and see if you can find some way to figure out where the asymptote is. We already know where the asymptotes are, right? Where are they? Where it says undefined. So we can tell by looking at the table where the asymptotes are. What we're trying to figure out is, can we do it without the table? So compare the function with the table and see if they're related somehow, besides the fact that you got the table from the function. You got it? Okay. One person thinks they know. You think you know? Okay. You think you know? You think you know? Okay. So first of all, I appreciate you guys not shouting it out, giving everybody a chance to think. I appreciate that very much. Okay. Bella, tell me what you think you know. Oh. See, that's an interesting way that you put it, because some people earlier said, oh, it's just the opposite of what's there. Well, is that... Oh, that's true for the first three, right? But not all the time. It doesn't work here. I can't just say it's at positive 12, because it's not, right? Very clearly and appropriately and properly, you've got to set the denominator equal to 0. If you do, is that where the asymptote shows up? Look, equals 0. X equals 2. Oh, look where the asymptote is. At 2. But the best part of that is when you actually set it equal to 0, you get the asymptote. X equals 2. By solving the equation, you have found the asymptote. Does that make sense? You don't have to remember if it's x equal or y equals. You just solve the equation, right? When we did horizontal asymptotes yesterday, if the exponents were the same, we just kind of covered up the rest and look at the leading coefficients. Look what's there. Y equals that. Isn't that where the asymptote is? So you're not having to memorize what variable to use for what asymptote. You know, because you either have the y there or you have the x there, because of how we're setting it up for you. Again, we're not having to memorize things. We're remembering our patterns. Okay? So what about this one? Set it equal to 0. What's our asymptote? X equals 6. Is that proved in the table? What about this one? Set it equal to 0. X equals negative 3. Is that proved in the table? Okay, so this is where people start having problems if all they're doing is thinking of the opposite, right? But if I set it equal to 0, I get 2x equals 12. Dividing both sides by 2 gives me x equals 6, and that's proved in the table, isn't it? 2x plus 3 equals 0. If I subtract 3 from both sides, I get 2x equals negative 3. 3 over 2, right? Negative 3 over 2. Oh, look, that's the same as negative 1.5, isn't it? Set this equal to 0. 0.5x equals negative 2. Dividing both sides by 0.5 gives me negative 4. What about the last one? Excuse me. I add 4 to both sides, I get x squared equals 4. If I take the square root of both sides, what do I get? What's the square root of 4? What's the square root of 4? Plus or minus 2, right? We put the root sign in the problem, right? So we have to put the plus or minus in. So x equals plus or minus 2. Which one is more appropriate? This one or this one? They're both the same, okay? Sometimes people forget this is actually 2 of them. So if you're one of those people, write both of them. But if you can remember that this is 2 asymptotes, I'm okay with it. Okay? So answer some questions for me. Are these asymptotes related to the numerator or denominator? How can the asymptotes be determined using this part of the expression? I would like a really nice sentence. What's my nice sentence as my answer? What did you want to say? Set it equal to 0 and solve, right? That's what you wanted to say? That's what, like 3 or 4 of you already said, right? I would like a nice sentence. How are we going to write a nice sentence? It's a sentence. You can do this. Capital letter, which is going to be an A? Y? Period. The only way I think you can make this more clear is if you say you set the denominator equal to 0 and solve. But it kind of asks that, but it also doesn't say denominator in the question because that would be answering the question before it, right? So just be careful of that and you're fine. Got it? Look at the back, please. There's 2 samples that I'd like to do with you, and then you have the other 8 to do for homework. Okay? Each table shows values for a rational function. Identify the location of the vertical asymptote and then tell the domain. Where on the front did it talk about domain at all? They just throw domain in there all the time. Oh, you're okay with domain though now because of your project, right? Alright, so it's nothing to worry about. Guys, if we know where the asymptote is, don't we know where the domain is not? I'm going to say it again so you have a chance to think of it. If we know where the asymptote is, don't we know where the domain is not? Okay, so where's the asymptote on this problem? So what's my asymptote? X equals -2. So what's my domain? All real, except for -2. Now I'm okay writing it in this form, but I also make sure you need to know how to write it in interval notation. So let's make sure we remember how to do that. From -infinity to -2, and then it stops. -2 is not included, so it is a parentheses. Union, and then on the other side of -2 it starts again and goes to infinity. Got it? I mean, I'm just reminding you how to do that. You already knew, right? Absolutely. I almost feel condescending walking you through this next example because it's literally take x minus 7 and set it equal to 0 and add 7 on both sides, x equals 7. I hope I didn't sound condescending because I tried not to, but it's literally that easy. Can you do it? Okay, what do you do if you have questions? Come and ask, right? Ask your table group, come and ask me. I do have my answer key back here if you want to check as you go. Peace.